this lesson kind of takes the next step into trigonometry. It's going to use some things we learned, add a little bit on, and then also kind of see some stuff that would come in a pre-calculus course. So here, first off, we're going to look at trig identities, which are just equations that are always true. And these first two we've definitely done in our unit. So we know that the secant of theta equals 1 over the cosine of theta. The cosecant of theta is 1 over the sine of theta. And the cotangent of theta is 1 over the tangent of theta. Coming over here, our quotient identities are just writing tangent and cotangent in terms of sine and cosine. So we know tangent of theta equals sine theta over cosine theta. And cotangent of theta is cosine of theta over sine of theta. So all of these are kind of unique, except we have two identities for cotangent. And when we do simplification problems, we almost always use E. We don't really use C. So that's just a reminder. And that's because if you look at the other four, secant, cosecant, tangent, and the second version of cotangent, they only contain sine and cosine, which makes canceling and working with them easier. So here's our first problem. It says simplify the expression to a single trigonometric function. I have cosine of theta times tangent of theta. So this is cosine of theta. And in the place of tangent of theta, I can plug in sine of theta over cosine of theta. Now, since I have a fraction, I'm going to make the other part a fraction. When we multiply fractions, such as 1/2 times 4 over 3, we know that we're going to just create one numerator and one denominator so we can cancel any common factors. So in this case, the common factor we can cancel is cosine. So cosine of theta times the tangent of theta is just sine theta over 1, or just sine theta. With the second one, now we have a fraction, and we're going to plug in, we have our first chance to pick something for cotangent, and we almost always pick this one. So cotangent of y is equal to cosine of y over sine of y. And cosecant of y is 1 over the sine of y. So now we can keep change flip. And in this case, the sines cancel, and we get cosine of y. So in this particular section, we're starting to see that we do algebraic stuff with trig functions as well. And really, we do algebra with pretty much everything as you move on. It's just a tool that you can use for simplification and also solving in different situations. So the next thing we're going to talk about is the Pythagorean identities. So we know our basic Pythagorean identity, which comes from the unit circle that we learned in class. And that's sine squared theta plus cosine squared theta equals 1. Now, we can take this and we can create two other pretty simple identities just by moving stuff from one side to the other. So if I took the sine of theta and I subtracted it from both sides of the equation, I would have just cosine squared theta left on the left side of the equation, and I have 1 minus sine squared theta on the right side. So if I subtract, just to show that, from both sides, right, I get cosine of theta equals 1 minus sine squared theta. Equivalently, just another thing I can do is I could take the original and move cosine to the other side, cosine squared, and I would get the sine squared of theta equals 1 minus the cosine squared of theta. So this is our basic Pythagorean identity, and then just two other versions of it that might become helpful in different types of problems. Now, the other thing we can do is start to play around with dividing both sides of the equation by the same thing to create the second and third Pythagorean identities. So to find the second Pythagorean identity, I'm going to take the original Pythagorean identity and divide it both sides by cosine squared theta. I'm just writing it once. Everything is getting divided. So we're keeping our equality by doing the same thing to both sides. Sine squared over cosine squared is tangent squared theta. Cosine squared over itself is 1. And then 1 divided by cosine squared theta is going to be secant squared theta. So this is just another equation that's true, and we call that the second Pythagorean identity. It has tangent and secant in it versus sine and cosine like the original. So I would actually suggest pausing the video and see if you can find the third Pythagorean identity, which comes from dividing by sine squared of theta. You pause the video, come back, right? We just take our basic Pythagorean identity, divide the whole thing by sine squared of theta, which is going to give us sine squared over sine squared is 1, cosine squared over sine squared is cotangent squared theta, 1 over sine squared theta is cosecant squared theta. So that is our third Pythagorean identity. So other versions of each of those two just involve moving things from one side of it to the other. So looking at my second Pythagorean identity, I could move the 1 over, which would give me tangent squared theta equals secant squared theta minus 1. Moving the tangent squared over would be my other option, which gives me that 1 equals secant squared theta minus tangent squared theta. With my third Pythagorean identity, I could move the cotangent squared over, which would give me cosecant squared theta minus cotangent squared theta. Or I could move the 1 over, which would give me cotangent squared theta equals cosecant squared theta minus 1. So I will be honest, the basic Pythagorean identity and its two versions, I would say, is probably the most important ones that get used a lot. You do use the other ones, and it's just this idea getting into this notion of you can do a lot with trig to make new identities, write things in different ways. So here are a couple examples of questions that might arise from those. And remember, if you're watching this video, you're not in class, this is just little tastes of different things that you would spend a lot more time on. So it's not expected that you can do these proficiently. It's just, okay, that's different stuff I can do, and that'll be coming in the future, just kind of like a preview. So my first one, I have this fraction, and it kind of looks like I should be able to cancel the cosines, but since we have subtraction, we can't. But from this version of the basic Pythagorean identity, for 1 minus cosine squared theta, I can substitute sine squared theta. So my numerator, I'm going to leave this the same. And my denominator, I'm going to replace 1 minus cosine squared with sine squared because they are equal. Then looking at this, if I have cosine squared over sine squared, that's going to give me cotangent squared as my answer. And that's a single trig function, so we have simplified it further. The next one is proving, which means I need to do something to both sides of the equation until they become the same thing. So first I notice I have fractions on the left side, and I know to simplify adding fractions, I need a common denominator, which would be sine x cosine x. So my first fraction is missing sine x. My second fraction is missing cosine x. So when I multiply sine by itself, I get sine squared x. And then this is over sine x cosine x plus cosine squared x over sine x cosine x. And then on the other side, I'm just going to leave what I have. So I have 1 over cosine x sine x. So now I'm going to add the two green fractions together, keep my common denominator, and I'm going to add the numerators, which aren't like terms. Now, it looks, once again, tempting to cancel, right? We have sines and cosines here, but we have addition, which is that blocker, right? We can't cancel when there's addition. But I noticed that this whole thing equals 1 because that is the Pythagorean identity. So I have 1 over sine x cosine x equals 1 over, I'm going to switch these just so they match, sine x cosine x, that's just commutative property, and then it's